pH range is always from 1 to 14. Okay? Now, at the pH equivalent to 7, this is always a neutral point. This is the pH, exact pH of water. Water has a pH of 7 because it is a neutral point, okay?
Yes.
Water is neutral, is neither acidic or basic. Are we together? Yes. Therefore, as you move, the substance becomes more acidic when you move from 7 to 1. Acidic, the substance becomes more acidic. But when you move from 7 to 14, the substance becomes more basic. Okay?
Yeah.
That means that the substance that are close to 14 here, when you move from here to this side, then it becomes more stronger, then it becomes more stronger. But when you move backward towards 7, then it becomes more weaker. Meaning that we have two types of acid. We have strong acid and we have weak acid. Then we have strong base and weak base. Okay?
Yeah.
When we differentiate between strong acid and weak base, differentiate in them, we find that the strong acids here, they dissociate completely in aqueous solution. Okay?
Yeah.
They dissociate completely in aqueous solution, and therefore, by being dissociated, it means that they are ionized by donating a proton. Okay?
Yeah.
They donate a proton. For example, we have HCl is ionizing to donate hydrogen ion plus the chloride ion. This is hydrogen ion plus the chloride ion. The hydrogen ion becomes a proton. And therefore, acids, we say they are proton donors. Okay? They are proton donors. All acids, whether weak or strong acid, they are proton donors because they donate a proton. The proton here is the hydrogen. Okay?
Yeah.
We together. Explaining the proton will be another time. Okay?
Yeah.
Will be another time. Now, coming back to this one, the weak acids here will dissociate partially. You know, they dissociate partially. The word partially is they don't dissociate completely. Okay? It means that they don't dissociate completely. They dissociate partially. For example, look here. For example, we have CH3, COOH. This is the what? This is the toluene what? Toluene acid. This is toluene acid. Is an example, a very good example of weak acid. It is an organic acid, okay? And therefore, this one here will dissociate to give us hydrogen ion, which is our proton, plus ethanol ion, which is CH3, COOH, which is our negative. Is also aqueous. So you find that by dissociating partially, because there are some protons still in the molecule. Yeah. We have some proton, hydrogen here. It did not donate all their hydrogen ions, okay?
Yes.
But in the strong acid, they give all their hydrogen ions. For example, we have the sulfuric acid, we dissociate to give us hydrogen ion plus the sulfur ion, okay? Then the sulfur ion, to balance the equation, we put a 2 here. Therefore, the sulfuric acid here has donated two atoms, have donated all these hydrogen ions, all these hydrogen atoms that we are containing, okay?
Yeah.
Put together.
Yes. I have a question here.
Yes, please.
In the balancing of the equation.
Balancing the equation?
Yeah.
Okay.
How can you balance the equation and there is suppose that
how do we balance the equation?
Yeah.
Now, when balancing the equation is one of the easiest mechanisms. Okay? We have the hydrogen ion plus the sulfur. Okay?
Yeah.
Now we look at the reactor. This one here we call it the reactor what?
Reactant agents.
Reactant side.
Yeah.
And this is the product
Side.
side, right?
Yeah.
This is our product side. Now, you look at the reactant side and the product side. What are you observing? You are observing the atoms on the reactant side with the atoms on the product side. On the reactant side, we have the hydrogen atom. There are 2 atoms of hydrogen. And here there is 1 atom of hydrogen.
Yeah.
What do? You balance this hydrogen with this hydrogen by writing the 2 in front of the formula.
Okay.
Okay?
Yeah, yeah.
You write a 2 here, yes, here. So that the hydrogen atom become 2 as they are 2 on the reactant side. Are we together?
Yeah.
So here, the sulfur is 1 and is also 1. The oxygen, there are 4 and there are also 4 atoms there. That means it is balanced.
So the question is like this again.
Uh,
Some physicists they taught us if you balance the equation, the balance you balance the one like this. The whole equation here that the balance. Is it the reality or not?
Pardon? I'm not getting you well.
Like now, we balance this one.
Yes.
Hydrogen. Some teachers say that if you balance the equation like this one will share all the equation, which means you multiply 2 times the sulfur and the oxygen like that. They say like that.
Now, this is also is a different concept.
Yeah.
For example, we have different equations like this. I don't know what example can I give you. Equation. Okay?
Yeah.
The example I'm going to give you is take for instance we are reacting the carbon. Okay? This is carbon. Let me say we are reacting CH4 in presence of this is a combustion reaction actually, okay?
Yeah.
We are burning the methane gas in presence of
Oxygen.
in plenty supply of oxygen.
Yeah.
In order to give us carbon dioxide plus water. Okay?
Yes.
Yes, plus water. And therefore, this equation is not balanced.
Yeah, now it's balanced.
It's not balanced.
It's not balanced?
It's not balanced.
Because we have 4.
Hydrogen atoms
Yeah,
are
yeah,
4.
yeah.
And there are 2 hydrogen atoms.
Yeah. It's not balanced.
So what do? You balance for hydrogen atom by writing the 2 in front of the formula. Okay?
Yeah.
When you write a 2 in front of the formula, you find that hydrogen, this 2 multiplies this 2. 2 times 2 become 4. Okay?
Yeah.
Therefore, the oxygen, this 2 also multiplies the oxygen atom here.
Yeah,
So the oxygen also becomes 2. This 2 is for both hydrogen and oxygen atoms. Okay? So we shall have 2 hydrogen atoms and we shall have 2 oxygen atoms. Are we together?
Yes.
So the total oxygen atom become 4. 2 plus 2, 4. And here we have 2. That means we need to balance for oxygen atom also, right?
Yeah.
How do we balance? By writing the 2 in front of the formula. Okay? From there our equation is balanced. Are we together? Our equation is correctly balanced. Yeah. You can face it, you can see it properly, and then you can let me know if there is any problem as far as chemical equation is concerned. Is there something else you need? Huh?
No. Like in the reaction.
Yes.
In the reaction, the reactants in the left side.
The reactant side.
Yeah. When they react like this, you take the oxygen from this side to that side.
You then take the oxygen.
Yeah.
What happens is that when we are reacting with this, okay?
Yeah.
This is part of this one here is the
Organics.
organic reaction.
Exactly, yeah.
One of the organic reaction. And this organic reaction is known as the combustion. Anything that is combustion here we are burning, we need the burning.
The burning, yeah.
And when there is a burning, you are reacting substance with oxygen, okay?
Yeah.
When there is a burning, you are reacting them with oxygen. Are we together?
Yes.
You are reacting them with oxygen. Now, what happens is that
Yes.
when you
For
burn,
like now, how can you identify this one is a combustion reaction? How can you identify it?
how do you identify it? Because oxygen is there.
If you see the oxygen in the formula.
Anything in cold combustion will react with oxygen. Anything in cold combustion is reacting with oxygen automatically. Okay?
Yeah.
If I say that a substance will burn, let me say sodium hydroxide. Sodium amine is burned. Okay? Is burned in plenty supply of air. The word burn means there is a combustion. Okay? And when there is a burning, that means there is also oxygen. Because oxygen is the only gas that supports burning.
The burning.
Okay? All the gases don't support apart from oxygen. Together.
Yeah.
Oxygen is the only gas. That means that here we are going to react the oxygen gas of the sodium with oxygen. Give us sodium hydroxide.
Yeah.
Okay?
Yeah.
Or you can get sodium peroxide in case there is a plenty supply of oxygen. Okay? You can get sodium peroxide and sodium hydroxide.
Because of plenty of supply air.
Yes.
So, like now, the most question in the capsule which affect the stream, if something burn like this, they ask you what do you observe? What is the condition of the reaction?
Okay. Now, that is a very good question.
Yeah. What do you observe?
That is a very good question. Okay?
And what is the condition of the reaction? And those questions, see, you don't know the condition and you don't know what you observe.
When we are burning sodium in plenty supply of air, we observe the flame. The flame.
Yeah.
Okay?
Yeah.
You know the flame?
Yeah.
You have two types of flame. Luminous flame and non-luminous flame. Right?
Yeah.
So the flame here, the color changes in the flame is that this one here, the observation, this one burns with bright blue flame. Okay?
Yeah. Which means like
bright blue flame before the white precipitate. This one here is the solid. This is white in color. Okay? Now the question can come that if this product here, can come as a question B. If this product is dissolved in water, it is dissolved in the water, and then tested with litmus paper, what do you observe?
What do you observe?
And you write your equation for the reaction.
The question for the reaction.
Yes. Now this one here, sodium hydroxide is dissolved in the water.
Yes.
Okay? Give us what? This is sodium oxide dissolved in water to give us sodium hydroxide.
Yeah.
This is sodium hydroxide. Okay? Now our focus is the sodium hydroxide, which is an aqueous solution. First of all, anything called sodium hydroxide, it become a base. Right?
Yeah.
Then this base is treated with the litmus paper. Litmus paper. What do you observe? The observation is that when you treat bases with litmus paper, okay?
Yeah.
If the litmus paper turns blue, the litmus paper turns blue.
From green or when the litmus paper is red or
when the litmus paper is red, it turns blue. But when the litmus paper is blue, there is no color changes.
Okay.
No observable change. If the litmus paper is blue. That is for the case of the base. Now when we talk about acid later on, we find that the acid will turn to red. If the litmus paper is blue, it will turn from blue to red.
Okay.
Okay?
The question is like this. the equation you wrote. I'm still to get the concept of this equation. Yeah. How can you write this 2? Because they form the bronze or what?
Now how do we write 2?
Yeah.
Because it's not balanced, right?
No. I'm like the question you write now.
Yeah.
I'm still to get close with it. Because now the product is like that. Where did we get the water?
Where do you get the water?
Yeah.
Now, the water I say that is a product here, this product. We then treat it with water. This product is one that is treated with water. That means we put water into this product that is formed.
Okay. In the product forms.
In the product which is formed.
Okay.
We put the water here. Then this water, when we put the water here, then we add also the litmus paper. Then you say the observation, what is observed? The litmus paper turns from red to blue. In case the litmus paper was red. If the litmus paper was blue, then there is no color changes. Okay? There is no color changes. Now, in the reaction process, the reason why the litmus paper turns blue is because of the formation of sodium hydroxide. This sodium hydroxide hydrogen gas is also being formed here in the process because it is only the OH here, then the hydrogen atom. This hydrogen atom is then being displaced to give us hydrogen gas.
Yeah.
Together? Yeah. I think it's okay.
Yeah, it's okay.
Okay.
But this question, the question I asked you for, if the reaction takes place, the question, they put the question, what the condition take place? What is the condition of the reaction? Is it this one you wrote it now, or the condition of the question is what?
Now the conditions for the reactions are always very important, okay?
Yeah.
These are the important factors. Factors. Some reactions take place when there is temperature. Others pressure. Others catalyst. Others take place at room temperature. That means it's the same temperature. Can be standard temperature or room temperature. Or elevated temperature. Okay?
Yeah.
Then others can also depend on the concentration.
Like our question here, what is the condition of the reaction here?
The condition of the reaction here.
Yeah.
For this case.
Yeah.
Now, this one here is the presence of the heat. The heat here is the condition for the reaction because we are heating the bonding process. Okay?
Yeah.
That means the temperature. Okay? Now, for this case, this reaction takes place at room temperature. This reaction here, because it is the water and the reacting with sodium oxide. Okay? This condition takes place at room temperature.
The room temperature.
Okay?
Yeah.
Room temperature. Water forms sodium hydroxide and hydrogen gas. Okay?
Okay.
This is always the reaction of water with
And
oxide.
or-
This one we call them oxide.
Oxide, yeah.
Okay? And we have different types of oxides. Acidic oxide, basic oxide, amphoteric oxide, and many other oxides. Okay?
Let me take it as a easy way.
Yeah.
Like if the oxide react with water, the condition is take place in the room temperature.
Yeah, definitely the room temperature.
Okay. Then
You understand now?
yeah, I get the concept.
Good. We have been diverted from the topic we were discussing.
Okay.
All right.